And welcome back from a quick little break. So we're gonna see if we can't add a little bit of more color to the terrain. We're gonna add some grass and some dirt in that regards as well. So what we want to do is we're gonna start by creating two new textures, a grass and a dirt texture. And then we're just gonna test them out and see if they load into the game, and then we're gonna take it from there. So again, texture creation. So GIMP by, there we go. So we're gonna create something that's gonna look a little bit like grass. So what we're gonna start by doing is we're gonna find a nice grassy color. I think I'm gonna go with something like that. And then we're gonna paint. Yeah, that'll do. Then I'm gonna go for something fancy and add a layer on top of that. And we're gonna create a little bit of noise on that. We're gonna do something called plasma, because plasma is always fun. And we're gonna take that and we're gonna grayscale it a bit. Actually, no, we're not. Yeah, we're gonna grayscale it. I love my graphics card at the moment. Firefox is that. I have done. But oddly enough, it only happens. So there we go. So I was saying something about saturating this. There we go. So if we like turn down the opacity of this, we get some gray on top of this. That's not really the blend mode I'm looking for. Maybe more something along those lines. And then see if we can't add a little bit of random noise. Go for something like that. Yeah, that'll do for grass. So grass. And we're gonna export that same thing as grass PNM. That looks wonderful. Now we are just gonna quickly create a new image. Well, and I am going to copy this noise layer across. And we're gonna convert that to a new layer here. Turn the opacity down to something along the same lines. And then we're going to color our background, and we're going to color it some variant of brown. Maybe something like that. Not really happy with that. That's because this thing needs to be set into multiply, or perhaps something else. Yeah, that'll do for dirt. One thing you need to remember when doing this, it doesn't have to be pretty. Important is to get stuff done. So we've got two new textures. What I'd like to do first is say our stone has a base texture, and instead of being the stone, I want to try and use the dirt for a little while. So we're just going to clean. Oh, switch you over to, not that actually, but over to that. So I've changed the base texture for stone to be dirt right now for the stone material. I love the fact that it's called stone. We're probably going to want to change that at some point. We're just going to rebuild with that. So we're now linking, and we've linked. So if we refresh, we should get something brown instead. Most wonderful dirt texture ever, but it's definitely changed the look of this. So what we're going to start by doing is we are going to use, well, traditionally for this kind of stuff you'd do a texture atlas, but texture atlases in OpenGL are hellishly annoying. So what we're going to be doing instead is we're going to do an array texture. So what happens here is that we actually load multiple textures into the same, it's going to be sort of a 3D texture, but not really proper 3D. It's going to be an array texture. So we're going to load these 3 images into the same texture as different layers in the same texture. Now, we're probably going to, if we just run this, we're going to fail horribly because this is no longer a single texture and it's not a cube map. So we need to look at the material code again and load an array texture this time as well. So that's going to be fun. So if we refresh here, we get an exception thrown because we're trying to load base and it's not a map, but it's definitely not a string either. So just quickly, we are going to go into our material again here, and we're also checking not just for isMap. We happen to have the documentation open still. There is something called isSequence, which is most likely what we want. So I want to ask if it is a sequence. Let's see if it detects that. So yep, it is an array. Array in this case. So what we want to do is we want to add another case here. Else if texture.second is sequence, then we're going to do something else. And what I want to do is I want to create a standard vector of standard string, and these are going to be our files. Now for this we are going to try and iterate over texture second here. For file in texture second, I want to push back this file as a standard string like this. See if that compiles. Seems to do so. Now the thing about array textures is that they are not in OpenGL ES2, which is what WebGL 1 is based on. So we're not going to find them anywhere here. A moment ago we were looking through these texture 2D things, or the texture lookup functions and texture functions in general here, where we could choose between texture 2D and texture cube map. So what we want to do is we want to quickly grab an OpenGL ES3 reference card, because luckily there is also one of those. Same basic idea. So for texturing here, we have texture to image 2D, which is all nice and fine. Our bind texture has a target. Doesn't really describe what that target is. But the thing is, there's also something here, texture 2D array under text storage 3D. And if we go back here, there isn't any, let's see, text image 2D, copy text image 2D, text sub image storage, text. So it only has 2D textures, whereas 2D array is a 3D texture format and is what we want to do. So what we need to do in this case is that we need to switch over to OpenGL ES3, which means we switch to WebGL 2. Now, to do that, we need Emscripten to use WebGL 2. Emscripten WebGL 2. And OpenGL support here. To target WebGL 2, pass the linker flag as use WebGL 2 1. So we pass that in our linker here, where we're also giving a lot of other interesting flags to Emscripten. So now it should be using WebGL 2. And just to sort of check it out, what we can do is that we can, in our main function here, see if I can find it, there, main CPP. After we've done all of this, we've got our display, we've made the OpenGL context current. We can just quickly see out, can print out GL version by saying GL get string, and then we want to get the string GL version. So if we just quickly build that, switch over and refresh here and go up, we now have GL version OpenGL ES3 WebGL 2.0. So we're now running on a version that actually has these array textures. And you see right now we're not loading any texture for the terrain because we need to find that array texture. So I just want to add a new line here because we're missing a new line at the end. Anyways, so in this case where we're doing this, our texture type is going to be GL texture, not 2D, but GL texture 2D array. Let's switch over here. So 2D array. Now it's complaining that it can't resolve that. Thing is, somewhere there, we're including GL ES2. We want 3 instead, and hopefully that means that that's defined now. Great. And then we want to do texture handle load texture 2D array, and it's gonna get the files array here. So that looks good. Now we need to declare that. So in addition to load 2D and load QBAT, we have load 2D array, which does a standard vector of strings. Now, this one's a little bit interesting because we need to allocate storage for a lot of textures before we start. So what we're going to do is we're going to do GL ES material load 2D array There we go. So what I want to do here is I want to start with a GL uint texture handle, and we're going to initialize that to -1, and then we are going to work our way through the files. So for every file in our files, we are going to open that file. So we're going to have a texture, which is going to be our texture data, loaded from this file. Now, if our texture handle is -1, then this is the first file we're loading. In that case, we are going to generate a texture handle and we're going to bind it. Not as a texture cube map, but we are going to bind it as a texture to the array. We're also going to allocate storage. So we're going to go GL text storage 3D. And we're going to allocate a GL texture to the array. Now, first number is the number of mipmap levels, which we are going to take as 1. The internal format of this is going to be same as all the other ones, GL RGBA. Now, width is going to be looking at our texture data, get width, and then the height is our texture data, get height, and depth is going to be the number of files we have. So we're going to take a look at the size of our files. Now, at the same time, I really want to save these two out because I want to validate that the other textures that we load have the same width and height. Because if they don't, we should fail. So I'm going to save out a width and a height here. And these are size T's. Okay, great. So I'm going to have a size T width and height. So that's what we do if we haven't seen this texture yet. I'm also just going to quickly do a GL float here. No, GL int, which is our depth, is going to be 0. So we do all that else. This is not the first one. I want to assert that the textures data get width is equal to the width we already have. Otherwise, I'm going to fail with width. With array texture width mismatch. So function parameter count mismatch. Okay, assert is just one parameter. Fair enough. So we're going to assert that, and we're going to assert that the height is also equal to the height of the first texture that we loaded. That should ensure that we have valid data. So what we're then going to do is we're going to load in the data into our texture. We're going to do that using GL sub text sub image 3D. So our texture target again is GL texture to the array. We're going to load into mipmap level 0. Our x offset is 0. Our y offset is 0. Our z offset is our current depth. The width we're going to be loading in is we're going to load the entire width and the entire height. We are going to load a depth of 1. The format here is going to be GL RGBA. Our type is GL unsigned byte. And the actual pictures is the texture data dot get data. And then we increment depth and move on to the next image. And finally, we're going to return our texture handle. And that should actually load our 2D texture array. So we can link that, switch over, and try and reload. So text storage 3D invalid internal format. Specified text image has not yet been specified. Okay, time to look at reference material. Internal format. See text image 3D except for unsized base internal formats in table 3.3. Text image 3D. Internal format here. Okay, so this is where we have to actually specify a lot of stuff. So what I'd like to use is RGBA8 specifically. So here where we do the storage, we say RGBA8. Let's try that again. We link that. We're done. Let's try and refresh this. Still can't use F5. Texture has not been initialized prior to a partial upload, forcing the browser to clear it. This may be slow. This operation requires zeroing texture data. This is slow. At least it works. At least I'm thinking that works. So, having done that, we return that. We can now modify our fragment shader over here, because now we are actually going to not use a 2D sampler, but we actually need a 3D sampler. And we're going to sample this using a 3D sampler, and we're going to use a Vec3. And we're just going to index the first one as 0. So that should be layer 0. That should be the stone texture, if I'm not mistaken. We look here. Yeah, stone is at 0. So we are going to try and clean that and compile. And once we're done linking, there we go. We reload. So this looks promising. Must have a compiled fragment shader attached. Oh, yeah. So we're now sampling in 3D. So that means that our texture is no longer in OpenGL ES 1.0 GLSL. Where did it go? There it is. We are now working in version 300 ES. I believe it's the syntax.